Hello everyone, my name is N. Shivakumar, Department of Chemistry, Kamaraj College of Engineering and Technology. So in this session we have to discuss about the ultimate analysis part 1 session. So ultimate analysis, that is the analysis of coal. So in the analysis of coal there are two different types, one is proximate analysis and another one is ultimate analysis. So proximate analysis we have discussed the previous session, so that is moisture content, volatile matter and then ash content, fixed carbon content that can be analyzed qualitatively, so in the proximate analysis, whereas in the ultimate analysis it is called an elemental analysis. So here we have to analyze the carbon, hydrogen, nitrogen, sulfur and then oxygen. So and we have to analyze the various different types of elements by this ultimate analysis. So let us discuss about the ultimate analysis. So in this ultimate analysis we have to analyze the carbon and hydrogen, and next one is nitrogen content, then third one is sulfur content, then fourth one is ash content, then finally we have to analyze the oxygen content. So in that carbon and hydrogen content, it can be analyzed by combustion method, so it can be done by combustion apparatus. Then nitrogen content, it can be analyzed by Geldof method. So then in this sulfur content, it can be analyzed by bomb calorimeter. Then next ash content, it can be analyzed by proximate analysis that we have discussed earlier in the previous session. So that is proximate analysis. In that ash content is discussed, so that the same thing we have to discuss here. The next one is oxygen content. So oxygen content, so overall we have to find out the net analysis. So these are all the finding pathway of the determination of percentage of carbon, hydrogen, nitrogen, sulfur and then ash content and oxygen content. So first case is carbon and hydrogen content. So how we have to analyze the carbon and hydrogen content by ultimate analysis method. So it can be analyzed by combustion apparatus method. So here we are taken the known amount of the coal sample, it is taken and it is burnt in the current of oxygen. So that is by combustion method. So that apparatus is called the combustion apparatus. So here the carbon and hydrogen present in the coal sample are converted into carbon dioxide and water vapors respectively. So here the carbon, it is reacted with the oxygen by the means of combustion. So here it may forms as a carbon dioxide, and hydrogen, it is reacted with the in the current of oxygen, it may release as the H2O vapors. So these are form the simultaneous products. So from that we have to analyze the what is the percentage of the carbon content and hydrogen content. Hydrogen, it is burnt in the current of oxygen to produce the H2O vapors. Then this is the estimation of the carbon and hydrogen, so by the combustion apparatus method. So here the current of oxygen, so it will be flow by pure dry oxygen inletted here. Then this is the combustion tube, so this is a furnace. So here this is the sample of that is a crucible, it is taken, it is a sample of platinum, that is made of platinum crucible, and this is the wire gas it will be provided, that is copper oxide is provided. Then the combustion tube is connected with the two U-shaped tube. The two U-shaped tube, already we have taken the weighed sample of the KOH solution. Here this is the known weight of the KOH solution, it is taken, that will be taken as a X gram, and here anhydrous calcium chloride, it is already weighed sample is taken, that is taken as a Y gram. So it will keep it as a this is a Y gram and this is called the X gram. So this is the entire setup. So here when we are burned the coal sample in the crucible by the means of the current of oxygen, so all the carbon, it is reacted with the oxygen to produce the carbon dioxide, and all the hydrogen, it is reacted with the current of oxygen, it may produce the H2O vapors, so that can be evolved in this combustion tube. So finally these vapors will be absorbed by the already known weight of the KOH and that is anhydrous calcium chloride tube. So here that all the carbon, it is converted into carbon dioxide, that will be consumed by the KOH tube, and all the hydrogen it is converted into the H2O vapors, that it can be consumed by the anhydrous calcium chloride tube. So here it is given anhydrous magnesium perchlorate. So in that we have to take the anhydrous calcium chloride also. So that now the increase in weight of the KOH tube, it is taken as X, and the increase in weight of the that anhydrous calcium chloride tube, it is taken as the Y. So this is the whole set of combustion apparatus. Let us see the calculation of the carbon and hydrogen. Liberated carbon dioxide and H2O vapors are absorbed respectively by the KOH and anhydrous calcium chloride tubes of known weight. The increase of the weight of KOH, so it is due to the formation of the carbon dioxide, while increase in the weight of calcium chloride, it is due to the formation of the water vapor. So from the weight of carbon dioxide and water vapor formed, there will be a percentage of the carbon and hydrogen present in the coal. It can be easily calculated. So here this is the calculation. So what is the reaction inside the combustion apparatus? So here that the carbon, it is reacted with the oxygen and it may produce the carbon dioxide. So the carbon dioxide, it can be absorbed by the KOH and it may produce the K2CO3, potassium carbonate, and along with the water molecule. So then next cases, here hydrogen, all the hydrogen in the coal sample, it is reacted with the combustion of the oxygen, so it may forms as a water molecule. So all the calcium chloride, anhydrous calcium chloride, is reacted with the water molecules to produce calcium chloride heptahydrate, that is CaCl2 7H2O. So this is the overall reaction it is happening inside the combustion apparatus. So we have to take M is the weight of the coal sample taken. So whatever the weighed gram of coal sample we are taken, that will be represented as M gram. Then next one is X. X means nothing but increase in weight of KOH tube. So already we are taken weighed sample of the KOH in the U-shaped tube. So next in this case, so now the absorption of the carbon dioxide has happened due to the formation of the potassium carbonate. So now the increase in tube that is represented as the weight of the increase in weight of KOH tube is represented as X. Then the same case is Y. So Y is nothing but increase in weight of the calcium chloride tube. All the hydrogen molecules are reacted with the combustion of the oxygen to form the produce H2O vapors. That H2O vapors it is formed along with the already weighed calcium chloride. So then it forms the calcium chloride heptahydrate. So the increase in weight, it is happened in the calcium chloride tube, that it is represented as the Y. So now let us see the calculation. Percentage of the carbon. So carbon, it is reacted with the oxygen to form carbon dioxide. So carbon, what is the atomic weight? 12 is the atomic weight. So here carbon dioxide, 2 oxygen molecules there. So 16 plus 16, that is 32, along with the carbon 12. So that is the total weight is 44. So 44 grams of the carbon dioxide contains 12 grams of carbon. So therefore we are taken a X gram. So X gram is nothing but increase in weight of KOH tube. So X grams of carbon dioxide is equal to 12 into X divided by 44. That the same thing, M grams of the coal sample contains. M grams of coal sample contains 12 into X divided by 44. The next one is 100 grams. Suppose if we are taken 100 grams of coal sample contains how much amount of the percentage. So that we need to calculate 12 into X divided by 44, that is the same case, into 100 divided by M. So this is the formula to calculate the percentage of the carbon so present in the 100 grams of coal sample. So therefore percentage of the carbon is equal to 12 into X divided by 44 into 100 divided by M, that is equal to increase in weight of KOH tube, that is X is nothing but increase in weight of KOH tube, then into 12 into 100, there where M is the weight of coal sample taken. So weight of coal sample taken into 44. So percentage of carbon in coal is equal to increase in weight of KOH tube, then divided by weight of the coal sample taken into 12 divided by 44 into 100. So there we have to calculate the percentage of the carbon present in the coal. So from this we have to find out what is the percentage of the carbon present in the coal sample. So next we have to discuss about the how we have to calculate the percentage of hydrogen. The percentage of hydrogen, it is also calculated by similar pathway so of the carbon calculations. So here you can see that hydrogen, it is reacted, that is on combustion with the oxygen, so then it may reacts and it forms the water vapor. So here you can see the weight of the water molecule. So oxygen 16 is the weight, and then hydrogen, 2 hydrogen is present, so totally 18. So 18 grams of the water contains 2 grams of hydrogen. So therefore y grams of H2O molecule. Y is nothing but increase in weight of the calcium chloride tube present in the combustion apparatus. So here y grams of the H2O contains 2 into y divided by 18 grams of hydrogen. So y grams of H2O contains 2 into y divided by 18 grams of hydrogen. So this is the y grams. So the same thing, that is m grams of coal sample contains 2 into y divided by 18 grams of hydrogen. So m is nothing but what is the coal sample taken, we had taken, that is 2 into y divided by 18. So therefore 100 grams of the coal sample contains 2 into y divided by 18 into 100 divided by m grams of hydrogen. So here the percentage of the hydrogen in coal is equal to 2 into y divided by 18 into 100 divided by m. So that is the calculation. So or we can say that y we are already known. What is the y? That is the increase in weight of the calcium chloride tube. So what is meant by m? M is nothing but the weight of coal sample taken. So now we have to elaborately we can write down the equation. So percentage of the hydrogen is equal to increase in weight of calcium chloride tube divided by weight of coal sample taken into 2 divided by 18 into 100. So there we have to find out the percentage of the hydrogen present in the coal sample. So next one is nitrogen content. So first case is carbon and hydrogen that can be analyzed by the combustion apparatus method. Then second case is nitrogen content. So here the nitrogen content, it can be analyzed by Geldol method. Geldol, it is nothing but a long necked flask. So the vigorous reactions may be carried out by this kind of Geldol flask. The determination of nitrogen content can be carried out by Geldol's method. A known amount of the powdered coal sample we are taken, and with it is reacted with the corn sulfuric acid. So whenever we are treated with the sulfuric acid, concentrated sulfuric acid, it is a vigorous reaction. So here also this is the vigorous reaction, and in presence of the potassium sulfate and then copper sulfate as a catalyst. So in a long necked flask, that is called the Geldol flask. So why it is called Geldol's flask? So the flask, it is a long necked, and there the vigorous reactions may be carried out. So nitrogen in the coal is converted into ammonium sulfate and a clean solution is obtained. So nitrogen and hydrogen present in the coal sample, it is reacted with the corn sulfuric acid. It may forms as a ammonium sulfate as a clear solution. This is the first step of the reaction. So all the nitrogen, some hydrogens may be present in the coal sample, and along with the sulfuric acid, it may produce as a ammonium sulfate as a clear solution. Then in the second step, the clear solution is then heated with the excess of sodium hydroxide. So here this is a clear solution of the ammonium sulfate reacted with the excess of the sodium hydroxide, and it may produce as the ammonia. So here the ammonia gas may be liberated, and along with the sodium sulfate and water. So the liberated ammonia, it is treated with the n/10 of the standard solution of HCl. So it may produce as the ammonium chloride. So this is the third step. So first step, the formation of the ammonium sulfate. So and the ammonium sulfate is treated with the excess of sodium hydroxide. So then there will be a liberation of the ammonia and the sodium sulfate and water. The ammonia gas is reacted with the n/10 HCl. There it may produce as the ammonium chloride. So now the volume of the unused n/10 HCl. So here ammonia, it is reacted with the HCl, that is a used HCl. It may produce as a ammonium chloride. So unused HCl, that is, it is determined by the titrating it against with the standard n/10 sodium hydroxide. So here thus the amount of acid neutralized by liberated ammonia from the coal, it can be determined. So here from the titrated value, so where the unused HCl, it is being titrated with the n by 10 NaOH. So there we are getting the titration value. From that we can find out the what is the nitrogen content, or how the ammonia gas can be liberated, and what is the amount of ammonia or nitrogen that can be calculated easily. So this is the Geldal method. So here you can see that this is the long necked flask, so where the vigorous reactions can be carried out. So here this is the Geldal flask is connected with the Geldal trap and the condenser. So here all the ammonia gas can be liberated by the action. So here the coal sample is taken, and along with the corn H2SO4, and what is the catalyst, potassium sulfate or copper sulfate as a catalyst over here. Then it is reacted vigorously, it may forms as a ammonium chloride, ammonium sulfate as a product, then ammonium sulfate, then it is reacted with the excess of sodium hydroxide to liberate the ammonia. The liberated ammonia, it can be expelled over here. So then through the condenser, the ammonia gas is passed over to the n by 10 HCl. So the n by 10 HCl, here the used up ammonia, it may be converted into ammonium chloride. So the unused HCl, it being titrated with the what? So it is titrated with the n by 10 NaOH. So it is treated with the base. So this titration is called the back titration we have to done, and we are getting the value. So there we have to get the value and we are doing the calculation. So this is the calculation of the Geldal method. So the weight of the coal sample taken is m gram. So initial volume of the n by 10 HCl, that is V1, we are taken as a V1 ml, initial volume that is taken. Volume of unused, that is unused HCl, n by 10 HCl, that is V2 ml. So now the acid neutralized by ammonia, that is V1 minus V2 ml. So we know that 1000 ml of 1N HCl assimilarity is equal to 1 mole of HCl. So that is assimilarity is equal to 1 mole of ammonia. So that is HCl reacted with the ammonia 1 mole respectively to produce the ammonium chloride. So that is 14 grams of nitrogen or 17 grams of ammonia. So that only it will represent this equation. So next case is V1 minus V2 ml of n by 10 HCl is equal to 14. 14 is the atomic weight of nitrogen into V1 minus V2 into n by 10 divided by 1000 into 1n grams of nitrogen. So m grams of coal sample contains. So this is the same thing, 14 into V1 minus V2 into n by 10 HCl divided by 1000 into 1. So whereas 100 grams of coal sample contains 14 into V1 minus V2 into n by 10 divided by 1000 into 1, 100 into 100 divided by m grams of nitrogen. So we can consolidate it, we can write it, the equation, percentage of the nitrogen in coal is equal to 14 into volume of acid consumed, whatever the volume consumed, that is nothing but V1 minus V2 into normality divided by 1000 into weight of coal sample taken. M is the weight of coal sample taken into 100. So this is the percentage of the nitrogen in coal. Now we have to calculate the percentage of nitrogen in coal. We have to write down the simplified form. Here two zeros are cancelled and we have to return like this, 1.4 into volume of acid consumed into normality divided by weight of coal sample taken. So there we have to find out the percentage of the nitrogen present in the coal. So here this is the significance of the ultimate analysis. So how much important carbon and hydrogen and nitrogen it is. So carbon and hydrogen, we can see that hydrogen, higher the percentage of carbon and hydrogen, better the quality of coal and higher its calorific value. So normally carbon content is, if it is more, so the calorific value is also much greater, so it will enhances the fuel activity. So then next one is the percentage of the carbon, it is helpful in the classification of the coal. So various percentage of the fixed carbon content, so it may be analyzed into we can rank the coal into various different types. So that is the main significance. Another one is higher the percentage of carbon in coal reduces the size of combustion chamber carbon, if suppose. So these are all the significance of the carbon and hydrogen. So carbon, it may increases the calorific value. Then second case is in this ultimate analysis, nitrogen content. So nitrogen does not have any calorific value and in presence of the coal is undesirable. Nitrogen content is it is an undesirable one, so it does not present because it does not impart any kind of calorific values, so that is not important to the fuel. So good quality of coal should have very little nitrogen content. So for any kind of very good fuel, nitrogen content should be a minimum amount or minimum content it may be present in the coal sample. So this is the main significance of the nitrogen content. So apart from that, a carbon and hydrogen, nitrogen content, there will be a sulfur content may be present, ash content may be present, and then another one is oxygen content. So that it can be discussed in the later part of videos, that is a part 2 video of the ultimate analysis. Thank you.